In this video, we're going to use composition to verify inverse functions. So what we're going to do to verify that we do have two functions that are inverses of one another is we're going to compose them first as f of g of x. We should get an answer of x. And then we'll compose them again as g of f of x, and we should be left with an answer of x. So let's take a look. Here we have f of x equals 2x plus 5. Let's go ahead and find out what the inverse is, and then we'll use this test just to see how it works. So here again, I've got a function. If I want to find the inverse, I'm going to swap my x and y's. Now f of x is y, so I'm going to write this as x equals 2y plus 5. Let's solve for y. I'll subtract 5 from both sides. X minus 5 equals 2y. And I'm going to divide out the 2. I am left with x minus 5 divided by 2 equals y. So now I'm just going to go ahead. Let's write that as g of x. And that is my inverse. So what we're going to do is we're going to see. We already know these are inverses. We went ahead and we showed that. Now let's run it through the test. First, I'm going to do f of g of x. So I'm going to take my function f, and wherever I have the x, I'm going to put in my g of x. So my f is 2. Now where I see this x, I'm going to put in g of x. X minus 5 all over 2. And then I have plus 5. And now let's simplify. I can cross reduce right here. This is going to become 2 over 2. I am left with x minus 5 plus 5. And again, if I simplify this, negative 5 plus 5 is 0. I am left with x. Now let's go ahead and look at it by taking g of f of x. So now I am going to take my function g, and wherever I have this x, I'm going to input my function f. So here my x, I have 2x plus 5. That's my x minus 5 all over 2. Well, I can already see 5 minus 5 is 0. So I have 2x divided by 2, and again my 2's reduce out. I am left with x. So notice how when I took f of g of x, I was left with a result of x, and when I took g of f of x, I was left with a result of x. This tells me that these two functions are indeed inverses of one another. Let's take a look at some more examples. Here we're given two functions, and we're going to use this test to determine if there is an inverse relation here. So here we go. I'm going to do f of g of x. So here's my function f. I'm going to input my function g wherever I have the x. And g is the square root of x minus 5. I'm squaring that. There's my x squared, now plus 5. Okay, I'm going to have to distribute. I'm going to use, this is a polynomial identity. And so I'm just going to go ahead and use that identity. If you need to go ahead and write that out all the way and FOIL it, that's fine. So I'm going to have the square root of x times the square root of x. That's just x. Negative 5 times the square root of x, negative 5 times the square root of x. I'm going to double that. I get negative 10 times the square root of x. And now my last term, my c value, negative 5 squared, is positive 25. And now when I simplify this, I get x minus 10 times the square root of x plus 30. I cannot simplify this anymore. Since this does not equal x, we can already see that there no inverse relation exists. And so I really don't even need to try it the other way. Let's take a look at your try-its. Let's do A. Let's start out by doing f of g of x. F of g of x. So now wherever I have, I'm going to go to my function f. Wherever I have that x, I'm going to put in 4x minus 7. So I'm going to have 1/4 times 4x minus 7 plus 7. I should have left a little bit more room. So now here, my 4's here are going to cancel out. I'll be left with x minus, now I got to divide this 7 by 4 as well, so I get negative 7/4 plus 7. I could go ahead and get a common denominator and combine it, but you know what? It doesn't matter. You can clearly see here, I am not going to be left with just x. So this does not equal x. No inverse relation. Let's take a look at B. Start out with f of g of x. So again, here I'll start out with my function f, and I'm going to input x cubed plus 1 wherever I have x. The cube root, my x is x to the 3rd plus 1 minus 1. Let's simplify underneath the radical. My 1's cancel out. I'm left with the cube root of x cubed. And we know that the cube root of x cubed, well, that equals x. This is looking promising. Let's take it the other way. Let's go g of f of x. So now I'm taking my function g, and wherever I have this x, I'm going to put my function f in its place. So I'm going to have the cube root of x minus 1 cubed, that's my x cubed, plus 1. This exponent of 3 cancels out my index of 3, so this x minus 1 can leave the radical. And I am left with just x. Because I compose these functions in both directions, and I'm left with results that say equal x, this tells me that my functions are in fact inverses. So this, I'm just going to say, we'll just simply say they are inverses.